Can I please, Hannah, right here. Thank you. Okay, 7.5 today, exponential and logarithmic equations, what we're dealing with. So the first part, the example 1 on the worksheet you picked up, a lot of that should be a review. So these problems, the 1 through 12, hey, you're welcome to get your textbook out and use example 1 out of the textbook for help. But that's the part I want you doing right now off that worksheet you picked up on the way in, the 1 through 12. Okay? So, go for it. You guys are going to spend about 10 minutes or so on that. Okay? Do your best. Work together. Gentlemen, I am going to pause some of you. I know we haven't spent the full 10 minutes before I said I'd come up and put up answers, but I see, just walking around that brief time, I see some of you just cranking everything into your calculator, which takes you a lot of time. You should be able to look at this and know your cubed roots. What number cubed is 27? 3. That should be something you've memorized by now. Okay, if you haven't memorized it, you should probably start writing out your perfect cubes up through 5. At least through 5. Probably 6 would be helpful as well. Okay? Know that 5 times 5 times 5 times 5 is 125. Okay? Okay? 4 times 4 times 4 is? 4 times 4 times 4? 64. Yeah, 16 is 4 by 4. That's all right. 3 times 3 times 3 is 27. So if you're sitting at your desk right now going, well, I don't know that. Well, that just means rather than using your calculator every time, you got to estimate and take a guess and then see if you're correct. It also may mean you just write them down on top of your paper real quick. Your perfect cubes, your perfect squares. You write them down. It takes an extra minute, but then they're there, and you've practiced them as you wrote them down. Okay? This one right here, a bit different. You would want to get rid of that cubed root first. The opposite of taking the cubed root of something is cubing it. So we cube that side. These cancel. I'm left with x plus 1 equals, and we cube that. That's 8. Then subtract 1, x equals 7. Okay, so see a lot of you paying attention. Good job. If you're not paying attention, I'm just assuming we know how to do these. You've kind of worked through equations like this before. So this is just a quick review. Okay, this right here, this is I personally like the fractional powers, but this one right here, some of you have it as x squared, and then you did the cubed root. So you're going that route, and you're going to break it apart differently. I personally would just say I want x to the first power, which means I'm raising this power to the reciprocal, the 3/2 power. When I multiply those, I now have x to the first. And so I take the reciprocal of this one. And remember, your numerator is what you're raising this to. Your denominator is what root you're taking. Okay? So this would be one of those cases where rather than pulling out your calculator and doing it on your calculator, you try to do it in your head. Okay? The square root of 4 is 2. Cubed is 8. And then you can check it using your calculator. Okay, yeah?
Would it be the same thing as having the 2/3 in front of the root?
Right out here?
Yeah.
No, the 2 is this being squared. That's taking the 2/3 root is what you're saying.
Yeah.
That's not the same, huh?
I still get E if I do that.
If you're taking the 2/3 root of 4, you're raising 4 to the 2/3 root power.
It's 2/3 root 4.
Okay, I'll look at what you're putting into your calculator. Yeah, you want to raise this to the 3/2 power, which is taking the square root and cubing it. Okay, this one right here, tell your neighbor what you raise it to. Good, 4/3. Okay, now when I look at that, I know that 125 to the 4th I can't do in my head, but I can take the cubed root of 125. What is that? 5. And then 5 to the 4th is 625. Okay. So I'm going to give you guys another couple minutes working on through 12 there. Okay. Jeez, let me move that focus and then try to... That didn't help. So let me finish up with these. Number 5, I'm going to take and raise it to the 4/3 power. Okay, these cancel. I'm left with x and the cubed root of 27 is 3 to the 4th, 81. Okay. And then this guy here, raised to the 2/5 power. Okay. And the 5th root of 243. That one you may not have memorized, but it is 3. If you recognize 243 as power 3. And then squared is 9. Okay. This guy right here, raised to the, thank you, raised to the 3/2. 3/2. We get, they cancel. I'm left with y is. Okay, square root is 9. Cubed is. What is it? 729. Okay, and then let's add 2. We get 16. So x to the 4/5 equals 16. Raised to the 5/4 power. 5/4. And those cancel. I'm left with x is equal to the 4th root of 16 is 2 to the 5th, 32. Okay, everyone tell your neighbor what you got for 9, 10, 11, and 12 real quick. All right, here we go. So this one right here is x to the 1/2 power, subtract 3, we get x to the 1/2 is -4. Now, this is saying the square root, remember, x to the 1/2 means that. You can't have the square root of a negative. This is no solution. Okay, now I realize that some of you may have used I there. We're not going to use it. We're going for just real solutions here. So if you used I, good job. However, we're going for real solutions. This one, we subtract 12. We get x to the 4th is equal to -9. It's again, on this one, there's no way to raise something to the 4th power and get a negative. That can't happen. This is no solution. Okay. Any questions on those two? Okay. Number 11, add 3. X to the 1/4 is equal to 5 raised to the 4th. That gives us x equals 625. And last one, divide by 3 first. Get rid of that 3 first. X to the 2/3 is equal to 100. Raise it to the 3/2 power. Those cancel. X is equal to, that gives us 1,000. So we take and raise that to the 3/2. Square root is 10 times, or to the 3rd is 1,000. Okay. Now, tell your neighbor what part you struggled the most with in that section. Any questions? Okay. Well, let's go ahead and move on then. I want you to take a look at number 16. Okay? Number 16 on your paper. All right? Go ahead and read the directions there. All right, a volunteer to read them. What do the directions say on 16? Go ahead, Hannah.
Solve each equation, check each solution.
Okay. Solve each equation. We're going to check it. What is number 16? 8 to the power of n equals 12. All right. Now, without using any different bases on our calculator, okay? Because remember, on your quizzes and your tests, you're not going to be able to use some of your graphing calculators. You're going to have to use scientific. Okay, so for those of you that use the different base function on your calculator. That's not going to be a good thing for you, at least during this chapter. So if we don't know how, a good statement to write down today is if you cannot solve something when in exponential form, then you should change it to log form. Okay? If you cannot solve something in exponential form, then change it to log form. Okay? And then I guess the other route is also true. If you cannot solve something in log form, then change it to exponential form. And that is going to seem, it's going to seem pretty, like a pretty simple statement right now, but it's something you're going to have to keep in mind the whole time we're trying to solve these equations. Okay, we good? So how many can solve that in exponential form? All right. Well, then let's go ahead and take that and let's write it as a log. Everyone write it as a log right now. Okay? Let's go ahead and give it a go. So if we have that, we have log base 8 of 12 equals n. Everyone get that? Now how many can solve that one? Without your change of base on your calculator, or without your base function. Okay, so I've asked you to do that. It didn't seem to work, all right? However, I will tell you, you keep wanting to go back to these, all right? I'm going to show you another way, okay? Just draw an arrow. It's okay. Oh, I thought you were, like, upset. Oh, all right. Oh, what? Don't yawn. It's exciting stuff, okay? We're going to take our 8 to the power of n equals 12. And just like, let me see, let's say you have just a quick previous problem. Let's say you had 4 and you had x squared. What would you do to solve that? You impose a square root, right? Everyone agree? Okay, you can impose whatever you want. A square root on its own, if I just say, hey, what's the answer to that? You'd go, it's pretty radical, but I can't figure it out. Right? Okay. Just like that, you can impose a log to both sides just like you do a radical. So what I'm going to do is I'm going to take the log of this. I'm going to impose the log. So I'm just writing log, and I'm writing log. So to make it a little neater for you and maybe bigger, I'm saying now log 8 to the power of n is equal to log of 12. Okay? So you're imposing the log to both sides. Okay, everyone tell your neighbor if you understand what I've done there. Okay, how many are with me? Raise your hand really high. I need to make sure. Okay, if your neighbor cannot raise their hand, ask them if they've got it, please. Help them out. Okay, any questions? Guys, I'm walking through it slow because from here we're just going to start picking up pace. So we pose the log. Okay, we take the log on both sides. Now I have this. I can use the power property to get that n out. So by imposing the log, I can now take and get rid of that or move that in using the power property. Everyone with me?
Yeah.
Write what that would be just by moving the in. Okay, so the power property says I take this and I just move it out in front. N log, or n times log 8 equals log 12. How many did that? Tell your neighbor how to get n alone.
Divide by log.
Okay? What do I do? Divide by log 8. We go just back to our regular algebra. We divide it out. They're multiplying by log 8, so we divide it out. So n is equal to log 12 over log 8, or if you actually do that on your calculator now, what's log 12 divided by log 8? Approximately? 1.19? Okay, good. There we go. What you have just done there is called the change of base formula. Now, remember, if you have a scientific calculator, you don't have different bases on it. And I'm not letting you use your graphing calculator that will work in base 8. Then you would have to be able to take this form right here. Now, this is why I'd write it as a log. Take this form and write it directly to that. So you go from exponential to log and then write it as this. Now, you should be able to quickly come up from this form to that right there using the change of base formula. Tell your neighbor how you could go quickly from this to that. Look at the patterns. Okay, let's generalize it. If I have log base b of m, okay, that would be, in change of base, we always have a fraction on the other side. And always have log. And what are we changing to? Well, you can change it to whatever base you want. You can change it, I can make it base 8, base 9, base 7, base 6. I can make it whatever I want. Now, I'm going to choose base 10. Why am I choosing base 10? It's our common base, what our calculator works in. So I'm going to make it base 10, but I could call it 7 and 7. That doesn't matter. Where does the b go? The bottom. Now, it's not always going to be bottom, but the base always goes to the basement. Okay? Base goes to the basement. M goes up there. Master suite, yes. There you go. All right? So you have the 12, the big number goes on top, little number goes to the bottom. Okay? That is the change of base formula right there. Okay? How does that change? Well, like I said, you can make it any base you want. You can start at base 8 and go to base 6. You can start at base 2 and go to base 12. Okay? Any questions there? All right. I want you guys to try to take a look at number 34. Number 34, that is it right there. If you really want to use your book for help, you can. But first thing to do, I've given you the steps. Write it as a single log, write it in exponential form, and then solve for x. Give it a shot with your neighbors. Okay, so we're not done. How many have made it through the first step? Okay, well, let's write this as a single log. We're in equation form. You're taking this expression, what we've been working on the past few days, just that side of it, ignore the negative 2, and write that as a single log. Okay, well, that means the bases have to be the same. They are. The things in front have to be the same. They are not. How do I move that 2? Make it an exponent. So this is now log x squared minus log 5. Okay? Now, that's not the single log yet. Single log means you'd see the word log once. What do? I divide them, right? The same base. We keep that base, and we divide the 2. Now, please do not confuse that with the change of base formula. Change of base formula has log on top and the word log on top and the word log on bottom. This is the quotient formula, right? Stuff we've done, the quotient property. All of that equals -2. Raise your hand if you're with me. We've wrote it as a single log. That was your first step. These are steps to follow. If you can't solve this in log form, you should write it in exponential form. Okay, you need to get in the habit. What you're going to do is ask me for help, and then go, can you solve that in log form? No. What should you do? You're like, that's why I came up and asked you. Well, dude, that's what I'm telling you. Write it in exponential. Okay, so this is base what? Base 10. 10 to the negative second equals x squared over 5. Now, some of you, because you're really good with algebra, you just need to see something moving. Okay, well, here's what's moving. That moves over and it transforms to that. Okay, there's the algebra for you. The x squared's there. Okay, now I didn't do much algebra. I'm just showing you something moving across an equal sign because you're familiar with that. Okay, but when you move that over, it becomes an exponent. Now you have this. Now, some of you may get confused like this, but this is exponential form. What is 10 to the negative second in fraction? 1 over 100. 1 over 10 squared, or 1/100th. Some of you are zoning out. You're like, okay, this is tough. I'm about done. Okay? You now have a proportion. Proportions, how do you solve proportions? Cross multiply is the easiest way. That gives me 5. That gives me 100x squared. We are now solving for x. How do I get x by itself? Divide by 100. X squared equals 5 100ths. And then I take the root. X is equal to plus minus root 5 over root 10, or root 100, which is 10. So x equals plus minus root 5 over 10. Now, the question is, can I have the plus minus? Well, that would mean I would put a negative number in for a log. Okay, now just think of any log. If I wrote, let's just take a piece of this, just this chunk out. If I have log x equals y, and I write it in exponential, that's 10 to the y equals x. Everyone agree?
Yep.
If I put a negative in here for x, can anything to a power equal a negative? No. My negative is extraneous. We get rid of that negative. Okay? So it's just the positive. You don't even need to put positive. Just get rid of those. That is your solution, which I believe is approximately 0.22. If my math is correct, and if I can remember from when I looked earlier. Okay? All right. Now, questions on steps within that? Tyler?
Are we able to move the log form?
Right here?
Yeah.
Because that's just changing from log to exponential form. Just what we've been working on for the 7.3 and 7.4, right? Going from one form to the other.
So I'm still kind of confused of why you don't do the why the answer would be plus minus 0.22. Like I don't really.
Why it wouldn't be negative?
Well.
Or why it would?
Like why it couldn't be? Oh wait. Yeah. Why it couldn't be negative? I don't really get that.
Because if you take just the piece out that has the x,
Yeah.
and you put that here and then write it exponentially, so move the log over. You're saying 10 to a power, any power, would equal a negative number. So think about what you know about exponents, and as you start raising things to powers, is there any way to ever get a negative number? The answer is no. Therefore, it can't be negative. Yeah?
So all you're doing is moving the base over, right?
Right here?
Yeah. So if it would have been like log 9, it would have been 9 to the negative 2 or.
Correct.
Okay.
Yep. It's just the same stuff we've been working on. It's just now part of the puzzle, right? So all those little things we've been working on are now all in one chunk. Okay. Your assignment, take a look at the worksheet. You have completed 1 through 12. You're going to cross out 13 and 14. Unless you want to do them for extra credit. I'm not concerned about them right now. Okay. So you really are down here on 15 through 36. Now, I will tell you that tomorrow we're going to do something where you need to know how to solve some of these if you're going to be successful. However, I'm not going to actually grade this assignment. The answers will be up, but we won't grade it or collect it until Monday. That does not mean you shouldn't do them tonight. However, some of you are going to go to recognition night. Some of you may have other things tonight. I would suggest you at least attempt a chunk of each part tonight. That way you have some questions to ask tomorrow. And then you can finish the rest that you need to over the weekend. Tomorrow's going to be review. You won't get any extra homework, or you shouldn't get too much extra homework for the weekend. Okay? But you need to try a set out of each part here. Okay? That would be my suggestion. And then over the weekend, if you wanted to finish the rest of them, you could. That clear? Questions? So example side, all, with the exception of 13 and 14. Okay? All right. Very good. All right. So one thing that's going to help some of you, I know I've said if it's as an exponent and you can't solve it right as a log, if it's a log, you can't solve it right as an exponent. Here's an even different way of looking at it. If you look at a problem and the variable is in the power position, that should be a very quick hint it needs to go to log form. Unless you know how to do that in your head. Like if you knew 10 to the 1 point whatever power is 182, or the 2 point whatever power is 100. If you knew that in your head, which I don't, then you could just write the answer. But since the variable's in the power position, automatically you write it as a log. And then if it's not base 10, do the change of base formula on it. Okay?
So if it's base 10, would you just plug it in?
If it's base 10, you could just plug it in. If it's not base 10, like this is going to be base 8, from this point, on this one, you do the change of base after you write it as a log. So you go, right? Log base 8 of 12 equals n. This is the one we did earlier. Then you just go, well, I know that the change of base says the big number goes on top, little goes on bottom, and that's going to equal n. That's what you put into your calculator and calculate. Okay? Hopefully that's a little helpful.